Hi guys, so now let's do this question paper which was written in March 2023 for grade 11, right? Looking at question 1, we are asked to solve for x. So 1.1, we are asked to solve for x for this problem here. So we have x into 5x plus 2 equals to 0. So what we're going to do is we're going to say x is equals to 0, or 5x plus 2 is equals to 0. Then transpose the 2 to the other side. We have 5x is equals to minus 2. Divide by 5 both sides. We have x is equals to minus 2 over 5. So these are our solutions of x for this problem here. I guess it looks simple, right? So now let's go down to 1.2. So 1.2, we are asked to solve for x for this one. Leave our answer to 2 decimal places. So whenever you see this, it tells you that you need to use a quadratic formula. I mean, you cannot factorize something and get decimals, right? So it's x equals to minus b plus or minus the root of b squared minus 4ac, right? Divide by 2a, which our a value is equals to. So before we even do that, you can see that it's not in standard form, right? So we need to write it in standard form. So we're going to say x into 2x minus 3 equals to 4. Multiply the x inside here and here. We have 2x squared minus 3x, and transpose the 4 to the other side. We have minus 4 equals to 0. So now it's in standard form, right? And then can continue and say a is equals to 2, which is this one here, and b is equals to minus 3, which is this one here, and c is equals to minus 4, right, which is this one here. Fine. So now we're going to substitute that into our quadratic formula. So it's minus into minus 3 plus or minus the root of minus 3 all squared minus 4, our a being equals to 2, our c being equals to minus 4. So it's divided by 2, our a being 2, right? Punch this in your calculator. Remember, we're writing in 2 decimal places, so you'll first get a side form of 3 plus root of 41 all over 4, or x being equals to 3 minus root of 41 over 4, right? And then in decimal form is going to be 2.35. Remember, it's 2 decimal places. X is equals to minus 0.85, right? So we are done solving this problem here. So now let's get down to another problem of solving for x, right? So now we're going to look at question 1.3, right? This one here. We have x squared minus x minus 6 is greater or equals to 6. So we are seeing an inequality sign, sorry. So what means is we have x squared minus x minus 6 greater or equals to 6. Transpose the 6 to the other side. We have x squared minus x minus 6 minus 6 greater or equals to 0. So it's going to be x squared minus x minus 12 greater or equals to 0. And then we factorize this, greater or equals to 0. It's going to be x and x here, and then we use factors of 4 and 3, right? These must be negative, this must be positive, and then because it's an inequality sign, we're going to find our critical values. So it's going to be x minus 4 equals to 0, or x plus 3 equals to 0. So it's going to be x equals to 4, or x equals to minus 3, right? So these are our critical values, not our answers. So what we're going to do is we're going to go to our number line and then indicate our critical value. So we have a critical value of minus 3, and we have a critical value of 4, right? So critical value. So what you're going to do is this. You're going to test values that are before minus 3, which is minus 4. You'll test it between minus 3 and 4, which I'm going to say 2, and then just after 4, which is can be 5. So it's just up to you which numbers you choose, as long as they are less than minus 3, between minus 3 and 4, and above 4, right? So which is these numbers that are indicated. So what you're going to do is this. you have your standard form, right, of x squared minus x minus 12 is greater or equals to 0, this one here. So you're going to substitute when x is equals to minus 4, right? So you're going to put, where there's x, you put minus 4. So meaning you're going to say minus 4 squared minus into minus 4 minus 12, right? And you check the answer that you're going to get, right? I'm literally punching as we speak. So I'm going to tell you now what I'm finding. Minus 12. So the answer that I'm getting here is 8, right? Positive 8. It's important to indicate the sign. So it's positive 8 when x is equals to minus 4, right? What does this mean? It means that values that are before this minus 3 critical value are positive. That's what it means, right? So let's test this x is equals to 2 now. So meaning when x equals to 2, just going to substitute here and put 2 squared minus 4 into 2. I mean, sorry, it's not minus 4, it's just minus. And then 2 inside minus 12 like this. So this is just minus here. And let me just punch and see what I'm getting. I'm getting minus 10. I hope you're getting the same thing. If not, let me know in the comments. So I'm getting minus 10. So what this means is numbers here are negative. Y values are negative when x equals to 2 is substituted, right? So this is how you're going to get these signs, right? And lastly, you're going to test x being equals to 5. Please do this on yourself. But the sign that I got at the end was a positive, right? Meaning that any value that is greater than the critical value of 4 will give you a positive sign. So once you've done this, now you are able to conclude your solutions of x, right? So you'll get so because your question says that we want the solutions of x when the y values are greater than 0. So anything that is greater than 0 is positive. So where is positive here? Here and here. So you're going to conclude by saying x must be less than or equals to minus 3. You're using your critical values to conclude. Or x must be greater or equals to 4, using another critical value to conclude. So these are your solutions of x for this problem here. If you didn't understand this problem, let me know in the comment section. I will help you out. Anyways, let's wrap this up. So now we're going to do 1.4. So 1.4, as you can see, we are having 2 to the power of x plus 2 plus 2 to the power of x minus 2 plus 2 to the power of x equals to 42, right? So what we can do is we can just simplify this and say 2 to the power of x multiplied by 2 to the power of 2 plus 2 to the power of x multiplied by 2 to the power of minus 2 plus 2 to the power of x equals to 42. What's common is 2 to the power of x, right? 2 to the power of x is common throughout, so we're going to factor it out. So it's 2 to the power of x into 2 to the power of 2 plus 2 to the power of minus 2 plus 1, right? Equals to 42. So punch this in your calculator, you're going to get something like this. So it's 2 to the power of x into, so what I got is 21 over 4, right? Equals to 42, right? So I'm going to cross multiply, meaning I'm multiply by 4 both sides. And then I have 2 to the power of x equals, sorry, not equals 2 because it's still 21, multiplied by 21 equals to 42 times 4. Then I divide by 21. I have 2 to the power of x equals to 42 times 4 over 21. Punch this in your calculator and you'll get 8, right? Which is equals to 8, but you know 8 is equal to 2 to the power of 3, right? So it's 2 to the power of x equals to 2 to the power of 3, and therefore x is equals to 3 because you're going to drop the exponent, right? Since bases are the same. So x is equals to 3 for this problem here. We are done solving this problem. Off to another one. So now we're going to do this third problem here of 1.5. We are given the sort of the root of 4x minus 11 equals to 2 minus x, right? So the first step you're going to do is you're going to square both sides. That's the first step you do in this side equation. So you'll remain with 4x minus 11 is equals to 2 minus x. So let me expand this. 2 minus x, so it's minus here. And then just going to find the product of this, the entire problem here. So it's going to be 4x minus 11 is equals to, so this 2 multiplied by these 2 is giving you 4. This 2 multiplied by this minus x is going to give us minus 2x. And then this minus x multiplied by these 2, it's minus 2x plus x squared, right? Because it's minus x, right? So to just write it properly, 4x minus 11 is equals to 4 minus, so this is going to combine into minus 4x plus x squared, right? And I'm going to transpose this to the other side. So we're going to have x squared minus 4x plus 4 minus 4x plus 11 equals to 0. So we're just going to collect like terms. So it's minus 4 minus 4x here, which is minus 8x, and then you add your 4 with 11. It's going to give us 15, so it's equals to 0. And then what you're going to do is we have your standard form of x squared minus 8x plus 15 being equals to 0. Then we factorize this problem here. We're going to have x and x factors of 15 such that they give you the middle term when you add or subtract. It's 3 and 5, right? So it's negative and negative. So x equals to 3 or x is equals to 5. So what you're going to do now, this is not the final answer, by the way. So you're just going to test and see if these solutions are applicable, right? What do I mean by that? You are testing to your original given equation, which is this one here, right? So where there's x, you're going to put in this value here. So the answer that you get on the left hand side must be equal to the answer that you get on the right hand side. So let me just do this example for you. So here we got x equals to 3, right? So meaning I'm just going to put in 3 where there's x. So it's 4 into 3 minus 11 equals to 2 minus 3. So I must get the left hand side equals to the right hand side, right? I must get that. If I don't, then the solution is not applicable, right? Doesn't count. So what I'm getting inside the square root is 4 into, I'm literally punching minus 11. I'm getting the root of 1 equals to minus 1 here because it's 2 minus 3. So the root of 1 is just 1 equals to minus 1. So these are not equal. At least if it was 1 equals to 1, then yeah, it was going to be equal. But they're not, meaning that x is not equals to 3. So we're going to test for 5 now. So we're going to say the root of 4 into 5 minus 11 equals to 2 minus into 5, right? So let's substitute, punch that in your calculator. So what I'm getting here is the root of 9 equals to minus 3. So it's 3 equals to minus 3. So these are not equal, right? Meaning x is not equals to 5. So here we actually don't have a solution for this problem here. Imagine doing all this work and there's no solution. But yes, this is where you need to end it, right? So yeah, we're done with this problem here. We are done with this problem here. So we're just going to do question 2 now, which looks interesting. 2.1, we are given this expression here. We just need to simplify it without the use of a calculator. What I advise you to do, simplify with the calculator by seeing the answer. I mean, it helps. Just punch this in your calculator and see if you're going to get an answer. And then you know what you're working towards, right? So that you don't get frustrated when you're struggling solving the problem. You are able to see where you're getting it wrong, right? So yeah, otherwise we don't use the calculator to solve it. We don't. So anyways, this problem here is quite interesting and simple, I believe. And so what you do here is you just find a way to manipulate it, right? I'm going to show you now. So as I'm writing it, 7 2008 plus the root of 7 all squared. So you're going to manipulate this problem. What you do is you just choose on which power to use, and you must be what can I say, consistent with that power, right? I'm just going to choose 2008, right? You can choose 2011, it's up to you. You can choose 2009, it's just up to you, right? You can choose any power to use throughout, right? The main aim of choosing one power is so that you'll be able to simplify it, and just cancel out the common problems, right? So this is what you'll do. Well, this is what I'll do. So I'm going to take, as I said, I'm going to take 7 to the power of 2008, sorry. So by so doing, I mean I'm going to make everything to the power of 2008, right? So I'm going to do this here. I'm just going to say root of 7 to the power of 20. Instead of writing 2011, I'm going to write 2008, right? Plus, so for me to get 2011, I have to add with what? With 3, right? So literally I did nothing, I just simplified this. And then for the other one of 2009, I'm going to say 7 to the power of 2008. To get 9, I have to do what? I have to just add 1, right? And then the other one, 7 to the power of 2008. So I have to do nothing there. So that's what you do. You make sure that everything is the same. So it's going to be the power of 7 to 2008 plus 3, right? And then minus the root of 7 to the power of 2008 plus 1 divide by 7 to the power of 2008, right? 2008 plus the root of 7, right? So now that you've done this, this is what's going to happen. Since the first one here, we have the root of 72008 plus 3, right? So you're going to expand it. So meaning you're going to say the root of 72008 multiplied by 7 to the power of 3. So that's how it looks, right? The same goes with the other ones. So meaning we're going to have the root of 72008 multiplied by 7 to the power of 3. It's all inside the square root, minus the root of 72008 multiplied by 7 to the power of 1, right? All divided by 72008, right? Don't forget the root of 7 here, all to the power of 2. I'm going to rewrite this properly here, so that you're able to see what I did. So it's the root of 72008, right, multiplied by 7 to the power of 3 minus the root of 72008 multiplied by 7 to the power of 1 divided by 72008, it's all inside the root, plus the root of 7, right? So what's common here? It's 7 to the power of 2008. That's what's common. So what we're going to do is this. Please don't scratch your problem. I'm literally trying to find space. So what you're going to do is this. So now that you are at this stage, you're going to multiply the square roots. So for example, this part here, I'm going to say the root of 72008 multiplied by the root of 7 to the power of 3. This is still the same thing, right? Minus the root of 72008 multiplied by the root of 7 divide by the root of 72008, right? Remember, it's plus the root of 7 all to the power of 2. So don't forget the 2. So yeah, then from here, this is what we're going to do. So we're just going to factorize the 7 to the power of 2008. So I'm going to say the root of 7 2008 into what remains, root of 7 to the power of 3 minus root of 7, and then divided by the root of 7 2008 plus the root of 7 all squared like this, right? So this will cancel out with this one, or will divide out, and then you remain with the following. You remain with the root of 7 to the power of 3 minus the root of 7 all over 1 plus the root of 7, right? So let me rewrite this at the top. So this is what we have now. So we have the root of 7 to the power of 3 minus the root of 7 plus the root of 7 all squared, right? So obviously here we have the root of 7 minus the root of 7, if you can see. So these will subtract each other, and then you remain with the root of 7 to the power of 3 to the power of 2, right? And then you need to write this in exponential form. So it's 7 to the power of 3 over 2 multiplied by 2, and then this 7 to the power of 3 over 2 times 2, this 2 will divide out this. You have 7 to the power of 3, which is equals to 343, if I'm not mistaken. Please check with your calculator, but I got 343 as the answer. So yeah, we're done with this problem here. It looks interesting, and I really believe that you guys understood it. If you didn't, please let me know in the comment section below. Anyways, let's continue and solve this simultaneous problem here of 2.2, solving for x and y. So this is our first equation, this is our second equation, so I'm going to write it down here. So it's 2x minus, let me write it properly. So it's 2x minus y is equal to 3, so we'll make it equation 1. And then x squared plus 5xy plus y squared equals to 15. I'm going to make it equation 2. And then equation 3, I'm going to form it using equation 1 because it looks simpler. So I'm going to transpose the 2x, so I'm going to remain it minus y is equals to 3 minus 2x, and then divide by minus 1 all sides. So I have y is equals to minus 3 plus 2x. So I'm just going to write y is equals to 2x minus 3, same thing. So I'm going to make it my equation 3. So it's y is equals to 2x minus 3. So this is my equation 3. And then from here, I'm going to substitute equation 3 into equation 2, right? So where there's y, you're going to put 2x minus 3. So it's x squared, which is this one here, plus 5x into, this is the y, so you're going to put 2x minus 3 plus into 2x minus 3 all squared equals to 15, right? It's going to be x squared plus, so I'm going to multiply here, find the product. This plus 10x squared minus 15x, and then plus, so this, I'm just going to find the product here. So it's 2x minus 3, 2x minus 3. This multiplied by this, it's 4x squared. And then 2x multiplied by this minus 3, it's minus 6x. The same here, it's minus 6x, and then plus 9. So it's 4x squared minus 12x plus 9. So I'm just going to write it 4x squared minus 12x plus 9 equals to 15, right? So I'm going to write everything up, transpose this 15 to the other side. I have x squared plus 10x squared minus 15x plus 4x squared minus 12x plus 9 minus 15 is equals to 0. So I'm going to collect the like terms, this, and this. I'm going to get 15x squared. Let me just do this so that I see that I'm done with it. And then this minus 15 and minus 12, I'm going to add it together, getting minus 27x, and then 9 minus 15, I'm going to get minus 6 being equals to 0. And then I'm going to divide by 3 all sides to just simplify it further. So I'm going to get 5x squared minus 9x minus 2 equals to 0. And then the factors of this problem here, so it's 5x and x, put the 2 here and put 1 here. So this is positive and this is negative. So 5x equals to minus 1 or x is equals to 2, right? So let me just remove this. So we are almost done solving our problem. So this is what we're going to do. So our solutions of x, we have 5x equals to minus 1 or x equals to 2, right? Divide by 5 both sides. We have x being equals to minus 1 over 5 or x equals to 2. So remember that our third equation, it was y is equals to 2x minus 3, right? So just going to use it on both the x values. Equals to 2x minus 3. So where there's y, you're going to put in. So for this one, we're going to put in this minus 1 over 5 minus 3, or y is equals to 2 into 2, which is this one here, minus 3. So the first y value is going to be minus 17 over 5, or y is equals to 1. So these are our solutions of x and y, right? So we're done doing the simultaneous of this problem here. So now let's go to 2.3. I hope you guys are enjoying. If you're struggling with anything that I just did, let me know in the comment section below. I will help you out. Anyways, so here in 2.3, we are asked to discuss the nature of roots for the following graph. So 2.3.1, right? If you can see here, this parabola doesn't touch the x-axis, right? It only touches the y-axis. So what does that tell you? It tells you that we don't have roots. We don't have roots, right? So if we don't have roots, the discriminant is less than 0, right? It's non-real, right? So that's how you're going to comment non-real roots, right? So 2.3.1, so that's how you do it, right? If you don't understand nature of roots, check the description of, I left the link for the video with nature of roots. Now we're going to go to this one here, which has this parabola, but now it touches the x-axis, as you can see, right? So it actually, so if you can see here, so we don't know obviously the x value of this turning point, but we know that y is equals to 0, right? We know that y is equals to 0. So here we know for sure that the discriminant is equals to 0, right? And when discriminants are equal to 0, we're having real roots, right? So yeah, that's how we solve this one. If you have a question on how we really go about solving nature of roots, as I said, I left a link in my description below. So anyways, let's get down to 2.4. 2.4, we are having this problem here, which says that we have a quadratic equation, and this is what you're given. We want to identify the value of k, for which these x values will be rational. So something that is rational, when you talk of discriminant, it has to be greater or equals to 0, basically, right? Because when it's greater than 0 and it's a perfect square, then it's rational, right? And when it's equals to 0, it's definitely rational. So these two apply. So you just need to combine them, and by combining them, we're having this discriminant greater or equals to 0. So we're going to say discriminant greater or equals to 0, and then what's inside the discriminant, remember the discriminant is equals to b squared minus 4ac, right, which is what's inside here. So we're just going to write what's inside the square root, which is 13 minus 2k, by the way, so let me write it properly. Minus 2k, it's greater or equals to 0, and then you transpose the 13 to the other side, we have minus 2k is greater or equals to minus 13, right? And then you divide by negative both sides, we have 2k being less than or equals to 13, right? Because when you divide an inequality sign with a negative, it changes, right? So we divide by 2 both sides, so k is less than or equals to 13 over 2. So this is our solution of k. So we're done with 2.4. So let's go to question 3. So now question 3, if you can see, we are given in 3.1, we are given this tan of theta is equals to minus 2 over 3, right? And we are told that sine is greater than 0. So meaning that if you have sine of theta, the number that's equal here must not be negative. It must be positive, right? So calculate using a sketch the value of cos theta multiplied by sine theta. So we first need to draw a sketch, right? So to draw a sketch, we are given this tan theta, this one here, which will help us to draw a sketch. So it's tan of theta. We know tan theta is equals to y over x, right? Meaning that our y, let's just take our y being positive. Why? Because this, we are told it must be greater than 0. And sine is actually y over r, right? So hence this y must be positive. So we're just going to make the y being positive 2 over the negative 3, right? So by going to our Cartesian plane, we know this is x, this is y. To represent our y value being 2, positive 2, let's say the positive 2 is here, and then the x value, which is minus 3, negative sign is here. And then you draw your Cartesian plane like this, right? Obviously you need to fit in properly, so let's do this, right? Yeah, so this is your theta, and now you can, so obviously here it's 2, and then here it's minus 3 here, right? The adjacent side. So now that you have your triangle, you'll be able to solve this problem here of cos theta multiplied by sine theta. But before we do that, we need to identify the radius r, right? R here. What is r? So r squared is equals to x squared plus y squared, right? Put the root on both sides. So you have r is equals to the root of, what is our x? It's minus 3 all squared plus our y is 2, so it's going to be all squared. So you're going to get the root of 13 as your radius. So it's the root of 13, right? So now we can solve the problem now. So we're having cos of theta. Cos, if you're looking at this theta here, cos is adjacent over hypotenuse, so the adjacent side is this minus 3. So it's minus 3 is the adjacent, and then over our radius of root of 13, right? And then for sine, it's opposite over the radius, right? So it's opposite, which is 2 over our hypotenuse side, which is the root of 13, right? And then what's at the top will multiply each other. So this minus 3 will multiply this 2 here, we'll get minus 6. Divide by, so when the root multiplies a root, we take what's inside, or we multiply with what's inside, which in this case, since they will multiply and we're having 13 and 13, we're just going to write 13, right? So that is the solution for this problem here, right? We are done solving this one, so let's go to 3.2. So 3.2, we are given this expression. We are asked to simplify it into a single trigonometric ratio. So the first step is, as you can see at the top, is sine of 360 degrees minus x. So if we draw our cast diagram, we know that 360 minus x lies in the fourth quadrant, right? Which is 360 degrees minus theta, or 270 degrees plus theta, right? So we know that here only cos is positive, sine is negative. So I'm just going to reduce that. I'm just going to literally write down sine of x. That's how we reduce this one here, right? And then we multiply by, because we have tan of a negative angle, it's going to be negative tan x, right? Divide by, so here we have cos of 180 degrees plus x, which lies in the third quadrant where only tan is positive. So this one will be negative, so it's negative cos of x multiplied by, so this, if you take a look at this, this is actually 1 equals to 1. Remember, it's an identity, so it's equals to 1. Sine squared a plus cos squared a is equals to 1. So you're just gonna multiply with that 1, and then from here we're just gonna write down the identity of tan of x, which is equals to sine x over cos x, right? So it's going to be sine x multiplied by negative, actually here it was negative, so it's negative here, sine x over cos x, right? And then we are just going to, obviously this sign will multiply with this one, making it positive, and then this sign will multiply this sign. We have sine squared, but before I do that, let me divide with what's at the bottom, minus cos x, right? So we're gonna have sine squared x over cos x, and then this I'm gonna say divide by negative cos x, and then I have sine squared x over cos x multiplied by negative 1 over cos x, and then this cos will multiply this cos x, and this negative 1 will multiply this sine squared x. We have negative sine squared x over cos squared x, which basically is equals to tan squared x, which is negative. So this would be your solution for this problem here. I hope we are getting the same thing. If not, let me know in the comment section if you feel like there's a mistake anywhere else. But yeah, this is what I got. Now let's get down to the last question. Let's get down to the last question. So as I said, if you are getting anything different, let me know in the comment section below. I hope you're having fun. It was really nice solving this paper, and I hope you're enjoying yourselves. So now we are going to prove this identity, prove that the left hand side is equal to the right hand side, right? So I'm just going to choose the left hand side. It looks simpler, so I'm going to choose the left hand side, right, to use. So the left hand side, right, I'm having tan of theta. So the identity of tan of theta is equal to sine theta over cos theta, right? So sine theta over cos theta minus, so I'm just going to write this as is, so it's going to be cos theta over sine theta. So just going to add this the way we add fractions, right? Find the common denominator, which is sine theta cos theta, and then this cos will cancel out with this cos, we remain with sine. Sine will multiply this sine at the top, so it's going to be sine squared theta, and then this sine will cancel out with this sine and remain with this cos, which will multiply with this cos, so it's going to be minus cos squared theta. I hope you understand that. And then I'm going to change this sine squared into cos squared x. Why? Because we are only having cos here at the top. It's going to be 1 minus cos squared theta minus cos squared theta divided by sine theta cos theta, right? And then I'm going to add these two since they are the same. It's 1 minus 2 cos squared theta all over sine theta cos theta. So as you can see, this is the right hand side, right, which we were given here, just to remove whatever I was writing here so that you can see properly. So now we can conclude and say the left hand side is equals to right hand side. Yep, so we're done with this problem here. We're done with the entire question paper. I hope you enjoyed yourself. If you have any problems or questions, let me know in the comment section below. Thank you so much for watching. If you haven't subscribed, yes, please do, and then see you in the next video.